Our solar system is a vast and dynamic place. Planets orbit the sun, each with its own story. Comets and asteroids hurtle through space, remnants of the early solar system. These celestial wanderers often collide with planets, leaving their mark on the cosmic landscape. Among these planets is Mercury, a small, rocky world closest to the sun. It's a place of extremes, with scorching temperatures and a desolate, cratered surface. These craters, far from being mere blemishes, hold clues to a violent and chaotic past. They are a record of cosmic impacts that shape not just Mercury, but the entire solar system. Mercury is a planet of mystery. Its small size and proximity to the sun make it difficult to observe from Earth. For centuries, astronomers could only speculate about its surface and composition. It wasn't until the space age that we began to unravel its secrets. Spacecraft missions like Mariner 10 and Messenger revealed a world scarred by countless impacts. These craters, some small and others spanning hundreds of kilometers, tell a story of intense bombardment in the early solar system. By studying these craters, scientists can piece together the history of Mercury and gain insights into the processes that shaped our cosmic neighborhood. Craters are not unique to Mercury, of course. They're found on almost every solid body in the solar system, including our own moon. But Mercury's craters are special. Because the planet has a very thin atmosphere, there is little erosion. This means that craters on Mercury can remain relatively unchanged for billions of years, preserving a record of the early solar system that is lost on other planets. These craters are like time capsules, offering glimpses into a period when the solar system was a much more chaotic place. By studying the size, distribution, and composition of Mercury's craters, scientists can learn about the types of objects that were colliding with planets billions of years ago. They can also learn about the processes that led to the formation of planets themselves. Mercury is a planet that has always captivated astronomers, even as it remained elusive. Nestled close to the sun, it's often hidden from our view, making direct observation a challenge. Its proximity to the sun also means that its surface experiences extreme temperatures, swinging from scorching heat to frigid cold. Despite its diminutive size, smaller than Jupiter's moon Ganymede, Mercury is a celestial heavyweight in terms of density. This suggests a massive iron core, perhaps even larger proportionally than Earth's. What led to this unusual composition? It's a question that continues to intrigue scientists. Unlike Earth, where erosion and geological activity constantly reshape the landscape, Mercury's surface bears the enduring marks of its past. With a thin atmosphere, there's little to shield it from impacts, and its ancient surface remains largely unchanged over billions of years. Imagine a canvas splashed with countless shades of gray, a testament to the relentless bombardment it has endured. These craters, ranging from small, bowl-shaped depressions to vast impact basins, are a chronicle of the early solar system's chaotic period, a time when celestial objects hurtled through space with reckless abandon. Each crater on Mercury is like a time capsule, preserving a record of a specific moment in the planet's history. The larger the crater, the more powerful the impact, and the deeper scientists have to dig, metaphorically speaking, to unravel the secrets held within. By analyzing the size, distribution, and structure of these craters, scientists can piece together a timeline of sorts, understanding the frequency and intensity of impacts over time. It's a forensic investigation on a planetary scale, revealing the forces that shape not just Mercury but the entire inner solar system. Imagine a game of cosmic darts, with Mercury as the target and asteroids and comets as the darts. These celestial projectiles, remnants from the solar system's formation, hurtle through space at incredible speeds, sometimes colliding with planets in their path. When an object strikes Mercury's surface, the result is a crater. The energy released during such an impact is staggering. It's like detonating billions of atomic bombs simultaneously. This energy vaporizes the impacting object and a significant portion of Mercury's surface at the impact site, creating a massive explosion that sends shockwaves rippling through the surrounding landscape. Section 2. A Symphony of Destruction, the Impact Sequence. The formation of a crater is a complex process that unfolds in a specific sequence, each stage leaving its own unique signature. Initially, the impactor punches a deep hole in the surface, creating a bowl-shaped depression. The immense pressure and heat generated at the impact point melt and vaporize rock, creating a superheated plume of material that blasts outward. As the shockwaves propagate, they lift and displace vast amounts of rock, forming a raised rim around the crater. Molten material ejected from the impact site falls back to the surface, creating a blanket of debris known as ejecta. Over time, the crater cools and solidifies, leaving behind a permanent scar on Mercury's face. Section 3. Reading the Scar's Crater. Morphology and its secrets. Craters are not just holes in the ground, they are complex geological features with distinct characteristics that reveal clues about their formation and the impacting object. The size, shape, and structure of a crater can tell scientists a great deal about the energy of the impact, the angle of impact, and even the composition of the impactor. For example, large craters often have central peaks, formed when the compressed rock at the center of the impact rebounds upward. The presence of multiple rings around a crater, known as multi-ring basins, indicates an exceptionally large impact, powerful enough to cause the surface to behave like a liquid. By studying these features, scientists can reconstruct the history of impacts on Mercury and gain insights into the objects that bombarded the inner solar system billions of years ago. Section 4. Echoes of Ancient Bombardment. The Late Heavy Bombardment. The number and distribution of craters on Mercury's surface suggest that the planet experienced a period of intense bombardment early in its history, a period known as the Late Heavy Bombardment. This epoch, which occurred roughly 4 billion years ago, saw a dramatic increase in the number of asteroids and comets impacting the inner planets, including Mercury, Earth, and Mars. The Late Heavy Bombardment had a profound impact on the evolution of the solar system. It's thought to have played a role in delivering water and organic molecules to Earth, potentially contributing to the origin of life. By studying the craters on Mercury, which preserve a record of this ancient bombardment, scientists can learn more about the conditions that existed in the early solar system and the events that shaped our cosmic neighborhood. Mercury's surface is like an ancient manuscript, its craters forming the words and sentences of a story written in the language of impacts. Each crater, regardless of its size, speaks volumes about the forces that shaped this small, resilient world. Some craters are relatively young, their features sharp and well-defined, hinting at recent cosmic encounters. Others, much older, bear the weight of time. Their outlines are softer, their features eroded by billions of years of exposure to the harsh space environment. Yet even these ancient scars hold valuable information. They tell of a time when the solar system was a more chaotic place, a cosmic shooting gallery with planets as the targets. One of the remarkable things about Mercury's craters is that they act as cosmic timekeepers. By analyzing the number and distribution of craters on a planetary surface, scientists can estimate its age and the rate of impacts over time. This technique, known as crater counting, is a fundamental tool in planetary science. On Earth, geological processes like erosion and plate tectonics constantly resurface the planet, erasing the evidence of past impacts. But Mercury, with its thin atmosphere and lack of significant geological activity, preserves its impact history with remarkable fidelity. This makes it an ideal laboratory for studying the bombardment history of the inner solar system. Some of Mercury's craters are not merely dents in the landscape, they are colossal impact basins, scars left behind by the most dramatic events in the planet's history. The Caloris Basin, for example, is one of the largest impact structures in the solar system, spanning roughly 1,550 kilometers. The impact that created the Caloris Basin is thought to have been so powerful that it sent shockwaves rippling through the entire planet, creating a region of chaotic terrain on the opposite side of Mercury. This event, which occurred billions of years ago, speaks volumes about the destructive potential of cosmic impacts. The violence that shaped Mercury's surface may seem like a distant memory, but it holds important lessons for understanding the history of our solar system and the potential threats that still lurk in space. By studying the craters on Mercury, we gain a deeper appreciation for the dynamic and often chaotic nature of our cosmic neighborhood. These craters are a stark reminder that impacts are a fundamental process in the evolution of planets. They have shaped not just the surfaces of planets, but also their atmospheres, climates, and even their potential for harboring life. The study of Mercury's craters provides a unique window into the past, allowing us to piece together the events that shaped our solar system and influenced the emergence of life on Earth. While Mercury might seem like a distant and unrelated world, its violent history holds valuable lessons for us here on Earth. The same cosmic bombardment that scarred Mercury also affected our own planet. The difference is that Earth's active geology has erased most of the evidence. By studying the craters on Mercury, we can estimate the frequency and intensity of impacts that Earth likely experienced in its early history. This information is crucial for understanding the conditions under which life arose on our planet. It also highlights the role of chance in the evolution of life in the universe. The craters on Mercury serve as a stark reminder that the solar system is not a static and peaceful place. Large impacts, while rare, are still a possibility, and they pose a significant threat to life on Earth. Understanding the mechanics of impacts and the nature of near-Earth objects is vital for developing strategies to mitigate these risks. By studying the craters on Mercury and other celestial bodies, we gain valuable insights into the composition and trajectory of impactors. This knowledge can help us develop technologies and strategies for detecting and deflecting potential threats to our planet. In a sense, Mercury's craters serve as a cosmic warning system, urging us to be prepared for the unexpected. Mercury beckons, unfinished symphony of discovery. Despite decades of study, Mercury still holds many secrets. Its unique characteristics, such as its unusual orbit, its massive iron core, and its tenuous atmosphere, continue to puzzle scientists. Each mission to Mercury, each new image beamed back to Earth, raises more questions than it answers. Future missions to Mercury, equipped with more advanced instruments and technology, promise to unlock even more of the planet's mysteries. By studying its surface composition, its magnetic field, and its interaction with the solar wind, we can gain a deeper understanding of the processes that shaped not just Mercury, but the entire inner solar system. The universe in a grain of sand. Reflections on Mercury. Mercury, the smallest and swiftest of the planets, might seem insignificant in the grand scheme of the cosmos. Yet, within its craters, within the stories etched on its surface, lies a profound truth about our place in the universe. It is a truth about the interconnectedness of all things, about the violence and beauty that have shaped the cosmos we inhabit. Mercury's craters tell a tale of cosmic violence, of a time when the solar system was a chaotic and unforgiving place. But they also speak of resilience, of the enduring power of planets to withstand the ravages of time and emerge as unique and fascinating worlds. As we continue to explore the cosmos, we carry with us the lessons learned from Mercury, a small but significant piece of the cosmic puzzle. Mercury's secrets, our enlightenment. Once a mere point of light in the telescope, Mercury has slowly revealed itself to us, unveiling a landscape sculpted by eons of cosmic bombardment. Its craters, far from being static scars, are dynamic storytellers, chronicling a time when the solar system was a much wilder place. They whisper tales of unimaginable forces, of fiery collisions that shaped not just Mercury, but the very fabric of our cosmic neighborhood. As we've delved into the depths of these impact craters, we've unearthed more than just geological history. We've glimpsed the processes that forged our planet, the forces that delivered water, and perhaps even the building blocks of life to our young Earth. In Mercury's battered surface, we see reflections of our own planet's turbulent past, a past largely erased by the relentless churn of plate tectonics and the erosive power of wind and water. The everlasting fascination of the first rock. Mercury, the first rock from the sun, holds a special place in our collective imagination. It's a world of extremes, a study in contrasts. It's a planet where scorching days give way to frigid nights, where the sun blazes with an intensity unseen anywhere else in the solar system. And yet, despite its harsh conditions, Mercury is a testament to the enduring power of planetary bodies. As we continue to explore the cosmos, Mercury will undoubtedly continue to beckon us, drawing us back with its enigmatic allure. Future missions, armed with advanced technology, will peer deeper into its mysteries, uncovering new layers of its history and revealing the secrets hidden beneath its cratered surface.